Welcome to Micrel TV. My name is Mike Jones and I'm a Senior Product Marketing Manager responsible for Micrel's Automotive Ethernet product families. Today I'd like to talk to you about the benefits of using standard Ethernet for automotive applications to provide complete network ubiquity. 100-base-TX standard Ethernet is already in the car today for onboard diagnostics and software download according to ISO 13400 specification. Its key advantages over traditional CAN-based methods is the speed, where a car can be reprogrammed in minutes rather than hours, reducing the overall cost of the OEM. Here, Ethernet shows its flexibility for utilizing existing standard OBD2 automotive connector and CAN cable instead of the traditional networking RJ45 and Cat5. We can see across each domain the use of many different physical layer buses, for example, MOST, CAN, and LVDS, each specific to the application. The disadvantage to this approach is that multiple buses require bridging, adding complexity and cost. Moving forward, standard Ethernet can deliver a single ubiquitous network for automotive. With the arrival of ADB, audio-video bridging, for real-time streaming, these many different traditional buses can be replaced by a single common physical layer. Only Ethernet can provide this. The vehicle now can benefit from transporting multiple applications over a single physical media, as well as the elimination of gateway bridging, which reduces complexity and cost. New applications in the car favoring Ethernet such as advanced driver assistance, infotainment and diagnostics on the go, i.e. while the car is moving rather than at a service center, differ from OBD in two ways. Firstly, they are real-time applications, and secondly, they need to meet EMI limits, typically over unshielded cable. So why standard Ethernet? Well, the reasons are no different for automotive than any other market where Ethernet has been successful. Firstly, and probably the most key, is its lowest cost of ownership. Multiple markets and multiple suppliers provide economies of scale for lower cost silicon and standardized bill of materials. Secondly, holistic solutions. Ethernet is much more than just a physical layer, but a total solution with complementary IEEE specifications such as Ethernet, energy efficient Ethernet, and power over Ethernet. And finally, strong roadmaps, future driven by its multiple growing markets, continued evolving IEEE specifications, and most importantly, supplier competition. In the next few slides, we'll see a closer look at an example of each of these key benefits. The Ethernet circuit diagram is relatively simple. The host processor is connected to the PHY via a standard MII digital interface. But here the key is that the PHY is a standard Ethernet device that is used for other applications as well, from, for example, industrial control to consumer. This provides high volume usage and reduces costs. A 100 ppm crystal or clock source is used to be standards compliant. However, in reality, available silicon can operate at a much wider range. Automotive can take advantage of this and reduce costs further by utilizing lower accuracy crystal. A major benefit for standard Ethernet in automotive is the minimal or no components required on the line interface between the PHY and the magnetics, simplifying the layout and enhancing signal integrity. Standard low-cost Ethernet magnetics can also be utilized, and of course, Ethernet will continue to utilize preferred common automotive connectors and wiring harness. 100-base-TX standard Ethernet already offers the lowest power PHY technology. Compared to gigabit technology solutions, power and cost is reduced up to threefold. Further enhancements in energy efficiency can be realized with the IEEE 802.3 AZ energy efficient Ethernet support, where here during idle periods, i.e. no traffic is being sent, the PHY can fall back into a low power sleep mode, reducing power consumption by over 50%. Standard Ethernet PHYs can also offer the ultra-low standby currents for automotive and wake up on signal detection through remote powering. In conclusion, standard Ethernet reduces heat and hence increases reliability and fuel efficiency. Automotive applications can benefit by optimizing standard power over Ethernet as defined in IEEE 802.3 AF or AT to provide all the benefits of PoE without adding any extra system cost. Let's take a closer look. The PSC side, power sourcing equipment, a standard DC-DC regulator can be used to provide power to the center tap of the Ethernet transformer. This is defined in the PoE spec known as phantom supply. This method provides common mode noise rejection at the PD, power device side transformer. Any noise from the PSC or picked up along the cable routing is coupled as common mode noise and hence is removed. By using a low voltage PSC voltage for automotive, for example 12 volts compared to the traditional 48 volts, a low-cost, low-voltage DC-DC regulator can also be utilized at the PD. In the return path, the magnetics provide ground isolation between the PSC and PD units. This isolation prevents radiating ground loops occurring when there are differences in the ground potentials at each side, something that is likely to be significant in a vehicle. We can now look at the optimization. The key difference is the elimination of the traditional PSC controller. The PSC controller typically performs a signature and classification handshaking process to first check if there is a valid PD connected and then to understand how much power is actually required. For automotive applications, this is all known and fixed, and hence the expensive PSC controller can be replaced by just a low-cost DC-DC regulator. At the PD side, typically a bridge rectifier required to prevent a short on the power supply if the RX and TX pairs are swapped can also be eliminated as the wiring is also fixed. So in conclusion, we can provide PoE for free in automotive applications. All the benefits of IEEE PoE are realized without any additional cost. Micrel has already demonstrated, along with competing supplier Marvell, that standard Ethernet can provide multi-vendor interoperability solutions while still meeting automotive EMI limits over unshielded cable. In this example, error-free interoperability was demonstrated over an automotive wiring harness consisting of 5 3-meter sections of low-cost unshielded flex-ray cable using 4 inline MQS connectors. The harness was manufactured by hand with a minimum of 5 centimeters of untwisted section of cable at each connector. This represents the lowest cost cable specification. So in conclusion, across all automotive applications, whether it's diagnostics, advanced driver assistance, or infotainment, standard Ethernet delivers. Thank you for watching Micrel TV. For more information, please go to our website at www.micrel.com or contact your local Micrel representative.